Yes, feeder cables from an outside generator can be run in seal-tight conduit to a point of entry to a house, with some very important considerations. Seal-tight, also known as liquid-tight flexible metallic conduit, or LFMC, is a flexible conduit often used for outdoor applications and for connections to motors or other equipment where flexibility or protection from liquids is needed. Several factors must be considered to ensure a safe and code-compliant installation. Firstly, the type of cable used inside the seal-tight conduit must be rated for wet locations. Common cable types like NMB, which is often used for interior wiring, are not suitable for wet locations. Instead, cables like THWN or THHN, which are rated for wet locations when installed in conduit, should be used. Alternatively, you can use a cable specifically designed for outdoor and wet locations, such as UF cable. Secondly, the seal-tight conduit itself must be properly installed to prevent water from entering. Use appropriate fittings that are designed for seal-tight conduit and ensure that all connections are tight and properly sealed. This will prevent moisture from entering the conduit and potentially damaging the conductors or creating a safety hazard. Thirdly, consider the fill capacity of the seal-tight conduit. The National Electrical Code, or NEC, specifies the maximum number of conductors that can be installed in a conduit of a given size. Refer to NEC Chapter 9, Table 1, and the associated notes to determine the allowable fill for the specific type and size of conduit you are using. Overfilling the conduit can lead to overheating of the conductors and make it difficult to pull the wires. Fourthly, ensure that the seal-tight conduit is properly supported. While seal-tight is flexible, it still needs to be supported at appropriate intervals to prevent it from sagging or becoming damaged. The NEC provides guidelines for support spacing in Article 350.30. The support requirements depend on the size of the conduit. Fifthly, consider grounding. The metal conduit itself can serve as an equipment grounding conductor if it is properly installed and all connections are tight. However, it is generally recommended to also include a separate equipment grounding conductor inside the conduit to provide a redundant grounding path. This is especially important for sensitive electronic equipment. Sixthly, the point of entry into the house must be properly sealed to prevent water from entering the building. Use a sealant or caulking that is suitable for outdoor use to seal around the conduit where it enters the house. This will help prevent water damage and mold growth. Seventhly, ensure that the generator is properly sized for the load it will be supplying. Overloading the generator can damage the generator itself and can also create a fire hazard. Consult with a qualified electrician to determine the appropriate size generator for your needs. Eighthly, install a transfer switch to safely switch between the utility power and the generator power. A transfer switch prevents backfeeding, which is when the generator power is fed back into the utility grid. Backfeeding is dangerous for utility workers and can also damage the generator. Ninthly, follow all applicable local codes and regulations. Electrical codes can vary from location to location, so it is important to check with your local building department to ensure that your installation complies with all applicable requirements. Tenthly, consider the length of the seal-tight run. While seal-tight is suitable for many applications, it may not be the best choice for long runs. For long runs, rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, may be a better option. These types of conduit provide better physical protection for the conductors and are less likely to become damaged. 11thly, ensure that the seal-tight conduit is protected from physical damage. Seal-tight is flexible, but it is still susceptible to damage from sharp objects or impacts. Protect the conduit from damage by routing it in a safe location and by using appropriate clamps and supports. 12thly, use appropriately sized conductors for the load. The size of the conductors must be sufficient to carry the load without overheating. Refer to NEC Table 310.16 to determine the allowable ampacity of conductors based on their size and insulation type. 13thly, consider the voltage drop. Voltage drop is the decrease in voltage that occurs along the length of a conductor. Excessive voltage drop can cause equipment to malfunction. Refer to NEC Chapter 9, Informative Annex D for guidance on calculating voltage drop. 14thly, install overcurrent protection devices, such as circuit breakers or fuses, to protect the conductors from overloads and short circuits. The overcurrent protection devices must be sized appropriately for the ampacity of the conductors. 15thly, consider using a ground fault circuit interrupter, or GFCI, protected receptacle for the generator connection. A GFCI will protect against electric shock in the event of a ground fault. 16thly, label all components clearly. Label the generator, the transfer switch, and the circuit breakers or fuses that are associated with the generator. This will help prevent confusion in the event of an emergency. 17thly, have the installation inspected by a qualified electrical inspector. An inspection will ensure that the installation complies with all applicable codes and regulations and that it is safe. 18thly, use a licensed electrical contractor. A licensed electrical contractor has the knowledge and experience to install the generator and associated wiring safely and correctly. 19thly, ensure that the generator is properly maintained. Regular maintenance will help to ensure that the generator operates reliably when it is needed. 20thly, store fuel safely. Store fuel for the generator in a safe location away from heat and ignition sources. Follow all applicable regulations for storing fuel. 21stly, consider the environmental conditions. If the seal-tight conduit is exposed to extreme temperatures or corrosive environments, choose a conduit and fittings that are suitable for those conditions. 22ndly, be aware of potential hazards. Working with electricity can be dangerous. Be sure to take all necessary safety precautions to protect yourself from electric shock. 23rdly, always energize the circuit before working on it. This means turning off the circuit breaker or removing the fuse that supplies power to the circuit. 24thly, use insulated tools. Insulated tools will help to protect you from electric shock. 25thly, wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. 26thly, do not work alone. Have someone nearby who can assist you in the event of an emergency. 27thly, if you are not comfortable working with electricity, hire a qualified electrician to do the work for you. 28thly, consult the National Electrical Code, or NEC, for specific requirements. The NEC is a comprehensive set of standards for electrical installations. It is important to be familiar with the NEC requirements before starting any electrical work. 29thly, check with your local utility company for any specific requirements. Some utility companies have specific requirements for generator installations. 30thly, keep detailed records of the installation, including the type and size of the conductors, the type of conduit, the location of the transfer switch, and the size of the generator. These records will be helpful for future maintenance and troubleshooting. 31stly, consider using a surge protector to protect sensitive electronic equipment from voltage surges. 32ndly, ensure that the generator is properly ventilated. Generators produce exhaust fumes that can be harmful if inhaled. 33rdly, install carbon monoxide detectors in the house to alert you to the presence of carbon monoxide. 34thly, familiarize yourself with the operation of the generator and the transfer switch. This will help you to operate the system safely and effectively in the event of a power outage. 35thly, practice using the generator and the transfer switch periodically. This will help you to become familiar with the system and to identify any potential problems. 36thly, create an emergency plan in case of a power outage. The plan should include instructions on how to operate the generator, how to switch between utility power and generator power, and what to do in the event of an emergency. 37thly, inform your neighbors that you have a generator. This will help to avoid any misunderstandings or conflicts in the event of a power outage. 38thly, be considerate of your neighbors when operating the generator. Generators can be noisy, so try to minimize the noise level. 39thly, do not run the generator for extended periods of time. Generators are designed to provide temporary power, not to be used as a primary source of power. 40thly, disconnect the generator from the house when utility power is restored. This will prevent backfeeding and will protect the generator from damage. 41stly, store the generator in a safe and dry location when it is not in use. 42ndly, protect the generator from the elements such as rain and snow. 43rdly, keep the generator clean and free of debris. 44thly, check the oil level and the air filter regularly. 45thly, replace the oil and the air filter as needed. 46thly, have the generator serviced by a qualified technician periodically. 47thly, keep the generator's manual in a safe and accessible location. 48thly, be aware of the potential for carbon monoxide poisoning. Carbon monoxide is a colorless and odorless gas that can be deadly. 49thly, never operate a generator indoors or in an enclosed space. 50thly, if you start to feel sick while operating a generator, get fresh air immediately. Ultimately, local codes and the specific installation circumstances play a crucial role in determining the best and safest approach.